Hey, seventh hour. Sorry, I had to leave you. I know, it's so sad. All right, so hopefully you have already taken care of your eggs. So if you have not done the following things, please pause this video and go do it. You should have weighed your egg. You should have measured the water that came out of your egg. You can pop your egg into the trash can. Make sure you put your hand way down in the trash can. Don't pop it in the floor. And then I want you to clean up the whole entire thing. Wash the graduated cylinders, hang them up. Clean the scales with Clorox wipes and clean the tables and put the scales in the cabinets underneath the lab tables, please, so that they're not out for the week that the weekend that I'm gone. Because sometimes our scales walk away. So if you would please clean all that up for me, appreciate it. Pause the video and then I'll see you in a sec. Okay, now that all the lab is clean and your data are collected, please put away your Chromebooks. You will be finishing your data tomorrow. So here's what's going to happen tomorrow. Mr. Neiman is going to be subbing for us, and we will do your quiz. So you have 5 minutes until your quiz opens. So when you come in tomorrow, get settled in, get ready to take a quiz. And then you'll have 5 minutes, and then the quiz will open automatically in Canvas. If your lockdown browser goes snafu on you, remember you just log out of Canvas. Don't log out of Chromebook. There should be a little circle in the top left corner that says account. Click on account. You can log out and then log back into Canvas, and your lockdown browser should work, okay? After you finish your quiz, which should only take you about 10 minutes or less, it's a 12-question quiz, all multiple choice. And once you finish that, then you will need to work on your egg lab. So your egg lab, you don't need to worry about it all today or at home tonight. You'll have about 35, 40 minutes to do it in class, and then you can turn it in, okay? Just remember, if you want to, I'll put the percent change formula on the board, but it's final minus initial over initial times 100, okay? And so, and also, we're going to write this down really quick. We are going to use 58.4 for our initial mass of our egg before we put it in vinegar. I weighed a bunch of eggs and got the average. I'll put that on the board too. Okay. All right. So all of that is going to happen tomorrow. And then on Monday, we'll start our cell organelle campaigns. And I already told you about that. All right, so what we didn't finish yesterday, so on the right-hand side of the board yesterday, I had passive transport up. And we did passive transport, and then we did diffusion, facilitated diffusion, and osmosis, okay? All of that should be good. Now, underneath passive transport, we are going to do active transport, okay? So this is the second type of cellular transport. There's a couple of different things that just 2 different types that you need to know. But the main thing about active transport is it uses cellular energy, uses ATP, and that's cell energy, to move molecules. And it's usually because they are too big or too charged to cross by diffusion, okay? Or it could be moving it against, moving molecules against. Ooh, scoot over. The concentration gradient. Okay, so that's going to be from an area of low to high. Sorry. All right, so that's active transport. That's what it does. So where passive transport didn't use any ATP, didn't use any energy, and it moved molecules from an area of high crowded concentration to an area of low spread out concentration. This one's different. This one has to use some energy. It's either because it's moving molecules against the concentration gradient, so it's basically squishing them into that crowded subway car, when you're trying to get off the platform that's all nice, crazy, and then you have to go into like this crowd. It's a lot of work to do that. So that's what they're having to do if they have to get rid of something. So if cells are producing toxins, even if there's more toxins outside the cell than inside, it will move them outside the cell. with active transport, okay? Or if the molecules are too big. If the molecules are too big or they have too high of a charge to get through at all, then they can actively transport them, okay? Okay, so our types of, now if you ever need to pause this video, just hit pause until you're finished. So our types of transport, active transport, are going to be, first of all, we're going to use a pump. And if I have time, I'll put animations on here, but hopefully I will. So a protein pump is the first kind. And that basically is like a protein channel, only it moves. And so a little bit of ATP will have to attach to it. And then it will change shape to force the molecules across the membrane. So it's like the molecules have no choice. It's like being, it's like having something in a little, I don't know, if you put up a little sheet and you put something in it and you just go like that, and then it flies up in the air. So yeah, it didn't have a choice. Like that's kind of how the protein is like, I'm changing shape and you don't have a choice. You have to go, even if you're moving to a crowded space, a high concentration area. Okay, so protein pumps, they are basically channels that use ATP to force molecules. There I go again, writing off the edge. Force molecules across the membrane. Okay. And so that's one way. So it looks very much like the aquaportin we looked at yesterday, except it would have like a little area for a specific molecule like our sodium or a potassium to fit in there. And then when the ATP attached, it would like change the shape of it and like force that across the membrane. Okay. And that means that it can move things that are like moving into an area of high concentration. It can squish them in there, even if they don't want to go. Okay, and then the other one is something called I'm going to put them on both on one line because they're like the same thing. Endocytosis and exocytosis. Okay. So endocytosis and exocytosis. Endo means into, and cytosis refers to the cell. And exo means out of, and of course cytosis is cell. And this is what we call like bulk transport. That's the K. Oh my goodness. Bulk, that's an LK. Bulk transport. So this is large molecules. All right. I'm going to put an animation on here to show you how it works. Basically, the cell membrane, whenever a molecule is too big for the cell, and this is like immune cells will use this all the time. We have several cells. If it's like they're bringing in something really large. So if they need something really big, the molecule will kind of like come up against the cell membrane, and the cell membrane will wrap around it like a little pocket, make a vesicle out of it, and it'll draw it in. And that vesicle that's around the molecule, whatever it was that it took in, is just a part of the phospholipid membrane. Like it's all phospholipids, like a cell membrane. So that little vesicle can then transport it into the cell. Now, if it's an immune cell, it's probably transporting it somewhere where it can be broken down, or wherever it needs to go. That little vesicle will take it there. Okay, and then that's endocytosis because it's coming into the cell. Exocytosis would be like if it had something large it needed to get rid of, or maybe a large protein that the cell created, and it needed to be moved out of the cell because it's going to say it's your stomach enzymes that are going to digest your food. Well, the cell's got to get rid of those and got to take it to where it needs to go because it doesn't need to be in the cell. It needs to be in the stomach, and so it'll wrap a vesicle around that. And we'll go through all organelles and you'll see how it works. It'll wrap a vesicle around that, and then it'll transport it to the cell membrane, and then it'll like squish it out. Okay, so that would be exocytosis. Okay, so in your notes, if I were you, I would draw one of these. Okay, so basically, oh, that was a nice noise. So once wherever you have your exocytosis, like draw your cell membrane. So, okay, and then here comes a vesicle. Okay, and it's coming this way. Okay, and then it's going to take this right here. I'm going to move cell membrane out of the way now. Might want to just watch this and then design your notes later. And then it's going to take its little vesicle wall right there, and it'll fuse into there. So when I have something in there, like say I have this nice little orange molecule in there, and then there's the orange molecule still in there. So this is step 1, step 2, and then there goes the orange molecule. Bye, exocytosis. Okay. And then if I wanted to make it endocytosis, I just change the arrows the other way. Right? Okay. Cool. That's endocytosis because it's coming into the cell. Coming into the cell, endocytosis. Okay, that is all that's going to be on your quiz tomorrow. So that's your sum total for your quiz tomorrow. So I need you to write this down in your notes, but not for the quiz. I need this for your lab tomorrow. So you're going to be doing your egg lab. And so this is osmosis vocab. So this goes with your osmosis, okay? We often called it tonicity. Okay, so I'm just going to have you write these words down, and then we'll draw some pictures, okay? Okay, so I'm going to write the definition, and then you can leave some space to illustrate them, or you can illustrate it out to the side. So hypertonic means high solute, and hypotonic means low solute, and isotonic means equal solute. But let me explain, okay? So first of all, what is solute? Got to know that. Solute is what is being dissolved. Okay. Pause if you need to, because I'm going to change this. I'm going to erase this. Solvent is what is doing the dissolving. So water usually. Okay. So water probably. Okay. What is doing the dissolving? Pause if you need to. And then solution equals solute plus solvent. So I think of it as lemonade. I'm making lemonade. Woohoo! That's going to be my solution. What do I have to do? I have to dissolve lemonade powder into water. And if I dissolve it all together, I'll have a solution of lemonade. I dissolve the solute into the water solvent. Okay? Okay, so now back to our little things here. Okay, so when we talk about osmosis, we have to be able to identify, and I'm only telling you this right now for your lab. So you don't have to memorize this tonight. Don't study it tonight. Just use this for your, for finishing your lab tomorrow. Okay, because it asks you what type of solution everything was in. So now that you have this, so if you have high solute, that means you have low water. If you have low solute, you have high water. And if you have equal solute, you have equal water. Okay, so first of all, you have to know that these terms are comparison terms. So like, I'm short, but I'm only short when I'm in a classroom with you guys. If I'm in a classroom of kindergartners, I'm tall, okay? So those are comparison terms. I can't say if I'm short or if I'm tall if I don't have something to compare it to, okay? Otherwise, it means nothing. So in this case, I can't say something's hypertonic or hypotonic or isotonic if I don't have something to compare it to. Those terms would mean nothing, okay? So then let me draw your little illustrations. And you can draw these along the bottom or on the side or whatever. Okay, so if I have a cup, here's my cup with my single cell in it, my egg or cell, whatever you want to call it, okay? I'm going to draw 3 of them because I'm going to do one for each situation. Okay. Then you would say, okay, so let's say I have 15% solute inside my egg. How much water do I have? If I have 15% solute, and I know that my egg has to have 100% of whatever it is, how much water do I have? That's right. You're so smart. 85% water. Okay. That says H2O, by the way. All right. So in my solution that I dropped it into, I have 25% solute. That says solute. It's hard to read these. 25%. So how much water do I have in my solution? I have 75% water. You guys are so smart today. Okay, so what's going to happen to my egg? Because water is the first responder, so it's going to go in first. So what's going to happen to my egg? I have 85% water inside. I have 75% water outside. What's going to happen to it? Right. The water is going to leave the egg to go balance, because you want to have equal water. That's all systems are looking for equilibrium. So it's looking for equal water. So your egg is going to shrink. Okay. Water is going to leave the egg. All right. So back to your little vocab. This one is a high solute, low water, right? High solute, low water. This is a hypertonic solution. Okay, and it's a hypotonic egg. Actually change that, right cell, because then you can use it in any situation, not just egg. Okay, so in this situation, I had a low solute, high water cell. So that's hypotonic. Hypo means low, and tonic means solute. So low solute cell, sure enough, lower than that. Look at that comparison. Low solute, high solute. In this situation, I had a high tonic solute, high tonic solution. So that means that I had higher solute outside my cell than I had inside the cell, which meant water needed to leave to go out. Water always goes towards the hypertonic. If you can find arrows pointing some direction, they're pointing towards the hypertonic. Okay. So let's do this one. So let's say we have, once again, we have 15% solute. And I'm just using that number. I'm just making it up. So it's like not any big deal. And then out here we had 9% solute. Okay, first of all, let's identify this as low. This is low solute. So hypotonic, because it's lower than 15. So 9 is lower than 15. Hypotonic solution. And 15 is higher than 9. So this is a hypertonic cell. Okay. And what was going to happen to my water? Well, and you can fill in the percentages for water if you want to, 85 and 91. So what's going to happen to my water? Water always moves towards the hypertonic. Okay. So now my cell is going to get fat. Cool. Okay. If you have questions, ask Mr. Lemons. And then, of course, the last one, we would do 15% solute here and 15% solute here. This one is isotonic. Iso is equal. Iso means equal. Isotonic, both cell and solution, because they have equal solute. So then what's going to happen to the water? It's going to move equally in and out. Water's never stagnant. It always moves. So you're going to see equal movement in and out. Your cell should be the very same as it was when it started. Okay? All right, so just use those as notes. After your quiz tomorrow, you can get out your notebook. During the quiz, of course, you have to have your notebook put away. But after the quiz, you can get your notebook out and you can use this to answer the questions in your egg lab. Let me just say this very carefully to you and make sure you understand that every single person has to turn in an egg lab that's their very own. So while you may have the same data because your lab partner has the same data as you, you cannot have the same lab. So make sure that you customize your graph so that it looks different from the red, blue original one. Also, if you're sharing data on a spreadsheet with your group, do not graph on that shared spreadsheet. Make a copy of it and then graph, because otherwise they'll end up accidentally pasting yours in there and you'll both lose points for somebody doing one graph and sharing it, even if it was unintentional. So make sure that you do that separately. Every single person turns in a lab. Okay? All right, last thing I want to do, get a whiteboard and a marker. Oh, wait. Actually, just pause me. I'm not going to sit here and wait. Pause. Jeez. Okay, get a whiteboard and marker. You got it? And I am going to review you for the quiz really quick. Now, if the bell rings and it's time to go, that's fine. All you need to do is clean off your whiteboards and put them away. And then I'll see you on Tuesday, okay? I don't know when the bells ring because I don't know what time it is because I'm just a video. All right, so on your whiteboard, I want you to draw an enzyme substrate complex and label it. I want you to label the active site, the enzyme, and the substrate. So draw an enzyme substrate complex and label it, okay? And then show it to Mr. Lemons and see if you got it right. Okay? Pause. Okay. Hopefully you all got it right. You know, you should have something. I'm going to do mine like Pac-Man shape. So the enzyme is the big part. The substrate is the small part. And it's what's going to either be broken down or put together with something else. And this right here is the active site. Okay? Cool. Next, I want you to erase that. And then I want you to draw a axes for a graph. So do your axis for a graph. Okay. Label your axes so that you're showing me the effect of temperature on enzyme activity, like your potato lab. Okay. So label your axes so that I see the effect of temperature on enzyme activity. You can pause me if you want. I'm labeling mine. Now I want you to draw a line graph that represents what you feel like a pretty typical, a general enzyme activity would look like in temperature, going from 0 degrees to 100 degrees, which is boiling Celsius. Okay. All right. I'm going to draw mine. Then you can look up and draw and see if you did the same thing I did. That's kind of ugly. Mine's ugly. You should see an optimal activity temperature. And then what is happening here? Why is that happening? Denature. Protein is not like its natural state. It's unfolding. It's not working. The active site is broken. Okay, erase that. Draw a phospholipid and label the phosphate, the lipid, hydrophilic, hydrophobic. Don't look up here until you're done. Okay, did you do it? Does it match mine? Okay, make sure you know that for the quiz tomorrow. And then you should also know that there are many of these like this, and then it's a double layer, like a little bilayer, and that there's proteins that span it. I don't think cholesterol's on your quiz tomorrow. Okay, so protein, channel, phosphate. Ooh, that's some ugly handwriting, etc., etc. Make sure you know that. Okay. The only other thing I think you really need to know is be able to do active and passive transport. So remember, active uses energy, passive, no energy. And then be able to like say this is diffusion, facilitated diffusion, osmosis. This is pumps and endo and exocytosis. Okay? All right. Have a fantastic weekend. Take your quiz tomorrow, finish your egg lab, turn it in all on your own, and then you'll do your cell campaigns on Monday, and I will be back on Tuesday. See you then. Bye. Have a great day. I miss you. See you soon.